Hi guys, welcome. Today we're going to do trigonometry. So first I want to start with the definition of the word trigonometry. So the Greeks basically call it trigonometry because the word trigono is going to be triangle and metry is going to be measurement. So if you think about it, all what we're doing in trigonometry is the measure of the triangle. So we're going to measure angles, we're going to measure everything that has to do with triangle is going to be called trigonometry. You're going to ask me, Vanessa, but there's no triangles right here. Well, yes, there is, and you're going to see why the 30, 60, 90 and the 45, 45, 90 triangle are critical to find what we call the unit circle. But let's start baby steps. First of all, what is degrees and what is radians? So you're going to see that you're going to see notations like 30, 45, 60, right? This is the same, guys. This is just a notation. And this is degrees, okay? And let's say that you want to change this to radians. Look what you do. So you click radians here, right? So look, you put 30, you grab the number, divided by 180 times pi. All what you're going to do basically is multiply, pi over 180. So then from here, you can simplify 30 over 180 is going to be 1 over 6, right? 1 and then 6 here. So this is the same as pi over 6. Let's go ahead and do 45. Again, I do 45 over 180 times pi, and then I simplify, right? And then 45 is going to be equals to what? Well, 45 is 9 times 5, right? And then 180 is equals to, so I have here 9 times 5 pi, and then 180, I can also say that this is 36 times 5. And then, look, 9 over 36 is going to be what? 1/4. So this is pi over 4. So this is how you get 30, 45. Let's just do one more. Let's grab this guy, 315 right here. So if you have degrees, right, and you want to convert it against to radians, and let's say you have 315, so what do? You do, okay, 315, and then you go ahead and you do 315 divided by 180, and then you put pi, right? Then you simplify. Now if I have 315, let's see, so 315 divided by 5 is going to be equals to, let's see, 63 times 5. And again, 180 divided by 5 is going to be 63. So this is going to be 36 times 5. Now, when you simplify here, look what's going to happen. 7 times 9, 7 times 4, and then you have the pi right here. And then, no, actually here, 9 times 4, I have it backwards. Okay, here. 7 times 9 and 9 times 4, there you go, this eliminates. And then this is how you have 7 pi over 4. So 7 pi is the same as 315, but this is 315 degrees. And in radians, is 7 pi over 4. So as you can see here, it's just basically the same measurement, but one is degrees, the other one is radians. What about if I want to do the opposite? Well, I think going from radians to degrees is much easier because look what you're going to do. Let's say that you have pi over 6. All what you're going to do, you're going to say that pi is equals to 180. So what you do is that you substitute, instead of pi, you do 180, and then you do 180 over 6, and that's equals to 30. Let's say that you want to do 7 pi over 4. Again, you substitute, instead of pi, you write down 180 divided by 4. Then you do, okay, 180 divided by 4 is going to be 45. 7 times 45 is going to be equals to 315. So as you can see here, going from radians to degrees is much easier, I think, than going from degrees to radians because you don't have to deal with those nasty fractions. Okay, let's understand this unit circle. Now, the unit circle is going to have what we call the so, and then ka, toa. I'm pretty sure you've heard many times the so, ka, and toa. This is basically like a way to learn like what is the sine, the cosine, and the tangent. So just, think about a sine, and then you can put whatever, sine of an angle is equals to O, that means the opposite, and this is going to make sense in 1 second, over hypotenuse. Cosine, that's the other unit that you have to remember, is going to be adjacent over hypotenuse, and then the tangent is going to be equals to opposite over adjacent. Now, as you can see here, the SOHCAHTOA is super important because they're going to ask you things about triangles. By the way, this math cheat sheet, you can find it on my website. You click my math tutor formulas, you click on trigonometry, and boom, you get this beauty right here. Now, look at this, trigonometry functions. Now, here you're going to have opposite, adjacent, depending on of the angle, okay? What do I mean by that? Well, let's practice. I'm going to go ahead and just erase this. You understand where the SOHCAHTOA comes, and then we're going to talk about the cousins of SOHCAHTOA. But I want you to understand this. If you have a triangle, so look how easy now this is going to be. Let's say that you have a triangle like this. Actually, let's make this more like a right triangle. Okay, so let's say that you have this triangle, right? And then we're going to call this guy A, this guy B, and this guy C. And they put the angle right here, okay? Who is the opposite? Who is the adjacent? Well, the opposite is going to be the size opposite of the angle. So in this case, the opposite will be BC, and whatever is not the opposite is going to be the adjacent. Now, the adjacent, if BC is the opposite, because remember, you go by the angle, then AC is going to be the adjacent. Now, you can ask me, hey, Vanessa, what about AB? Guys, anytime you have a 90-degree angle, the one across the 90-degree angle is always going to be the hypotenuse, and it's always the longest size. Now, let's go ahead and practice. So let's go ahead and say, let's say that you have a triangle like this, right? And we're just going to set it up. Again, we're just doing basic trigonometry. We're going to have another tutorial, but I just want to do basic trigonometry about SOHCAHTOA. Okay, so let's say that now the angle is right here. Can you identify who's the opposite, who's the adjacent, and who's the hypotenuse? All right, the first thing you should do is identify the opposite. Immediately I go like this, I make a line, and I say, oh, okay, the opposite is AC. Immediately I know that if AC is the opposite, by default, BC must be the adjacent, right? Let's put another color here. So BC is the adjacent right here. Let's actually make this green. And guys, who do you think is the hypotenuse? Again, it's going to be AB. So this is going to be BC, and then the hypotenuse, let's make it red, is going to be equals to AB. Now that we understand this, life is going to be much, 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 much simple, okay? Now, before I go to the triangle, let's understand, again, the units. Okay, so let's do a triangle. So now, how do they build the unit circle using triangles? And this is where the SOHCAHTOA comes. So look, let's say that you have this value right here, okay? And they give you, this is a unit circle, and you're here, right? And you're here. This is 90 degrees because look, what I'm making is like a triangle. It's like going from here to here, right? And then we're going to call this guy 30 degrees. Now, very important to know, x, y. X is going to be the cosine, and y is going to be the sine. And you're going to understand what I'm going to do right now. So let's say that they ask you what is the cosine and what is the sine of 30, and you only have this. Remember, they're calling it the unit circle because the radius, or the length from here to here, is always going to be 1. It makes sense. Unit means 1. So I already know that from here to here, which I'm going to call AB, my value is going to be what? Just 1. Beautiful. Now I'm like, okay, this is easy because from there I can figure it out. Let's go ahead. I can figure it out AC, and I can figure out BC. Before I start here, I'm going to identify who's the opposite, who's the adjacent, and who's the hypotenuse. So we have the opposite, the adjacent, and then the hypotenuse. I'm almost done, I promise. Okay, so remember, I go like this. So I'm like, okay, the opposite has to be BC. The adjacent has to be AC, because remember, you do the opposite, by default the other one's the adjacent, and my hypotenuse is going to be AB, which I already have. And that's when you go and you say, okay, so I'm going to figure out how to find BC. Let's see how much is BC, how much is AC. We already have the hypotenuse. So that's when you use your SOHCAHTOA. So I look at this and I say, okay, I have the hypotenuse. So that means that I cannot find the tangent because look, the tangent only has opposites and adjacent. But here, look, I have the hypotenuse. So you first figure out what you have. You say, okay, I have the hypotenuse. So it's either the cosine or the sine. Well, let's start with the sine. The sine of 30 is equals to opposite. Remember, SOHCAHTOA opposite. What is the opposite? Well, BC, right? BC divided by the hypotenuse, which is 1. Beautiful. Now I can see that I only have one variable. Which variable do you have? BC. So now I can go ahead and say BC is equals to sine of 30 times 1. Now, in another video, I show you how to do sine and, like if you didn't have a calculator, sine of 30 is the same as 1/2. So BC is the same as 1/2 times 1. BC is equals to 1/2. Notice that now I know that this piece right here is 1/2. So BC is going to be 1/2. Now I need to figure out the AC. You can ask me, Vanessa, can I do the Pythagorean theorem? Yes, you could if you wanted to, but listen to this. You can do the Pythagorean theorem or you can just do trigonometry. You can do the Pythagorean theorem as long as you have a 90-degree angle right here. Now, I need to figure out now the value of AC. Think about it. Should I get the sine, the cosine, or the tangent? Well, again, I look at my options and I say, well, I have the hypotenuse, right? And I also have the adjacent angle. Guys, 30 is opposite of BC, but 30 is adjacent to AC. That's the reason why you don't even need to look for another angle. You just use this guy. And you're like, okay, the cosine of 30 is equals to, right, adjacent. Do I know the adjacent? No, that's what I call it, AC, over hypotenuse. Beautiful. I go ahead and now I just say that AC is equals to cosine of 30 times 1. You go in your calculator, make sure that you are in degrees, because if you're in radians, you're going to get a different answer. And I see that AC is equals to a square root of 3 over 2 times 1, or a square root of 3 over 2 times 1. So this guy right here is a square root of 3 over 2. Now notice that I told you that X was the cosine and Y was the sine. Well, look at this. Let's go to our unit circle and let's find out what is the cosine of 30. Well, remember that I told you X is the cosine. So if I look at the cosine of 30 right here, look what I do. Now I can understand it because look, cosine of 30 is a square root of 3 over 2. Didn't we get that, guys, when we did the triangle? Let's see, let's move this over here. Yes, we did. Look, a square root of 3 over 2 is x. Isn't this point a square root of 3 over 2, comma, and then this is what? Y, 1/2? Well, now I can, look at this. So I can see here that cosine of 30 is a square root of 3 over 2. What about if I ask you what is the cosine of 135? Which value would you pick? X or Y? Think of this. They go in order. X comes before Y, and cosine, because it's C, comes before S. So if I ask you what is the cosine of 135, you're going to tell me negative square root of 2 over 2. What about if I ask you what is the sine of 240? You're going to tell me it's the Y value, minus the square root of 3 over 2. What about if I ask you what is the cosine of 315? You're going to look at the X value, negative square root of 2 over 2. So now you understand how a triangle can give you all these values. And all what you have to do is understand only 30, 45, 60, and 90, because these guys are going to be repetitive. Let's go ahead and do one more question and finish our section. So let's go ahead and do a triangle that, so how do they give you this? For example, let's say that we want to figure, let's say that we're here. Let's just make another triangle. So we're here, right? And then this guy right here. And then they tell me like, look, this guy right here, let's see. all the way here is equals to 210. Now notice this. This is x and this is y. And then this is here, like, you know, all the terms are here. I was going to put minus x and minus y, but I'm not. Okay, because that's confusing and that's not right. So I have my x and I have my y. So if I go from here to here, that's 210. And I'm going to be like, wow, but is it an easier way of doing this? Yes. Well, think of this. I don't know what is the cosine or the sine of 210. However, I know that from here to here, this is equals to what? 180. So I can deduct that the angle right here is going to be the difference between 210 minus 180. And I go to my calculator, 210 minus 180, and that's equals to 30. Guys, what does that mean? That means that this angle right here, and if I do here like a triangle, I can say that, look, I'm going to put it right here, and then right here, and then right here. I could say that this angle is not 210 because, look, all what I want is to make a triangle. That 210 is not what I want. I just want basically this angle right here because this angle is going to give me the x and the y. So look, I go like this, and then look, the 90 degrees is where? Right here, right? So this is degrees, and then this is 30. Now, let's make this guy much bigger. So you're here, and then you're here, right? And you're here, and then this. Remember, the first thing you need to do, and this is 30. So this is like if you are doing A, B, and C. I promise you, this is going to take 2 seconds. It's so easy. Okay. So I look at this, and I say, okay, 30. And then, first of all, let's identify who is who. From here, I know that the opposite is going to be AC is going to be the opposite, right? If I go across the 90s, I know that AB is going to be the hypotenuse. Now, remember that the unit circle, that's called the unit circle because the circle has what? A radius that is equals to 1. To 1, right? So from here, I know that AB is equals to 1. And by the way, in a unit circle, your hypotenuse is always going to be equals to 1. So you have here 1, right? And then from there, what I do is that I want, what else? Okay, and then I have CA, which is going to be called the adjacent. No, I'm sorry. AC is the opposite, and then I have CB, I'm sorry, CB, which is the adjacent, because if it's not one, by default has to be the other one. So let's just put it here. So let's just put here, CB is the adjacent. I'm almost done. Okay, so let's go ahead and do it. Now, if I want AB, again, I can use SOHCAHTOA, and I can go like this, and I can say the sine of 30 is equals to the opposite, AC, over the hypotenuse. The hypotenuse is just 1. Again, AC is equals to what? Sine of 30 times 1. AC is equals to sine of 30. We already figured out that that was 1/2 times 1, right? So I already know that AC is going to be equals to 1/2. If I do the same thing with the cosine like we did it before, notice has changed. Notice that these triangles are always going to be the same, 30, 45, 60. And then if I want the cosine of 30 is the adjacent, which in this case is going to be CB over 1. So CB is equals to cosine of 30, again, cosine of 30 is a square root of 3 over 2. And now I can finally say, okay, so AC, right, which we know that AB is equals to 1. Now CB, we know that it's a square root of 3 over 2. And then CA, we know that is 1/2. However, guys, we're in the fourth quadrant. Who is negative right here and who is positive? Well, remember in the fourth quadrant, this guy right here is going to give me what? A negative value. And then this guy right here is going to give me what? A negative value, because your point is in the third quadrant. Remember, this is the first quadrant, the second quadrant, the third, and then the fourth quadrant. That's the reason why this point right here is going to be equals to what? The x is going to be negative square root of 3 over 2, comma, negative 1/2, both negatives. I go to my unit circle and bagloom, bingo, look at that. Square root of 3 over 2, comma, negative 1/2. You might be confused right now. By the way, look at this angle right here. Remember how in geometry you remember that vertical angles were the same? Well, look, isn't this angle vertical to this angle? Isn't this angle here, right? Vertical to this angle here. So you're going to see that vertical angles are the same, but what it changes is the sign. Because think about it, positive and positive. Here, x is going to be negative, y is going to be positive, just like what you learn in, coordinate geometry. Negative and negative. Notice how everyone is negative here, negative, negative, negative. And then here, you're going to have the x, which is positive, and then the y value is negative. So this is how we do the trigonometry functions. This is part number 1. I just went through the basics of what you need to know. I would recommend you to watch this video at least 2 more times and then try to do yourself the triangle and trying to find, like 120, trying to figure out how to do one of them and see if you get the answer. Notice that you have to either get 1/2, a square root of 3 over 2, a square root of 2 over 2, and so on. And please, I made a video that shows you how to do the, what is it called? The unit circle in 3 minutes without memorizing it. So I'm going to go ahead and put it there. Again, if you want to access these formulas, you go to my math tutor, you click on formulas, you click here on trigonometry. And this cheat sheet, this is a nice cheat sheet. It's just basically show you, the trigonometry identities. You will not need this type of identities like to know them. You might see these identities on the ACT, but they give them to you, and sometimes you just have to plug in values. But other than that, if you are taking trigonometry, I highly recommend you to, I actually did this little cheat sheet for my students because I felt like everything you needed if you were taking trigonometry was basically here. So yes, enjoy it. I hope today you enjoy and you love a little bit more triangles. Trigonometry is beautiful. Once you understand trigonometry, the whole world is in your hands, especially if you love triangles. This is vanessagraulich. I hope you enjoyed. Have a good night. Look at that, 9:30 p.m. But we did it.